All right, for 10.2 day 1, we are learning how to work with parabolas. And last year when we worked with parabolas, we always had, y equals x squared or ax squared plus bx plus c. The standard equation wasn't the standard equation that we're dealing with this year. So it's a little bit of an adjustment. But your standard equation is going to end up looking something like this. So this is something that you will want to make sure that you remember. It's going to either be x minus h quantity squared is equal to 4p times the quantity y minus k. It's either that or the y minus k is over here and the x minus h is over here. So some variation of that. So this would be the other one. And we had this written down in our notes from class, so hopefully you already have that. And from last year, if you remember, x being squared, that was normal for us. So this one, the top one, means your parabola is either opening up or down like they did last year. When it's y squared, that's not normal for us, at least last year. That means they open to the side. And the 4p number, that number tells you whether it's up, down, left, or right. If it's positive, it's either up or to the right. Negative, it's down to the left. Alright, so when it asks us to find the vertex, focus, and directrix of this, the very first thing I should do is ask myself, is that parabola in standard form? Now, first of all, I can identify it's a parabola because I have one squared variable, the other one's not. So I know it's a parabola. So does it look like either one of these two? Well, not exactly. If you look at the standard form, the squared term should be on the left, and then the other term, the term that's not squared, should be on the right. So I'm going to leave the y minus 1 quantity squared on the left, and I'm going to subtract over the x plus 5 quantity, and I'm going to leave it as a quantity. I don't want to distribute that negative. Now it actually is in standard form. I've got a quantity squared over on the left, I've got a quantity with some number in front of it. Now I can go ahead and figure out what the vertex, the focus, and all of that stuff is. Vertex point, just set both parentheses equal to 0. So my vertex point, remember x is always first, is going to be negative 5. And then positive 1, there's the vertex point. There's one of the things I'm looking for. The focus, I'm going to kind of graph this here at the same time. It's just going to be a very rough sketch, so don't feel the need to put a bunch of points down if you want to. Alright, so negative 5, I got 1, 2, 3, 4, 5. Positive 1, it's right about there. And then I'm just going to glance at this. This is y squared. Well, y squared was not normal for us last year, so that means this is either opening to the right or to the left. Because that's negative, it's actually opening to the left. And so I'm actually completing the last part of this problem where it says sketch the graph. That's all I would need to see for the sketching the graph. I need to see that you've got the vertex in the right spot and have it opening the right direction. Alright, well, why do I like to see that picture? Well, if you remember when we said in class when you have to find the focus is always inside of that parabola. So because this is opening to the left, the focus is over here somewhere. So that tells me I need to move to the left. When, in other words, I'm going to be subtracting a number from that x value in the vertex point. So how do we get that number? That's what p is. So this number, whatever this is, if you divide it by 4, that tells you how far left, right, up, or down to move to get the focus. So I could say that 4p is equal to negative 1, and then of course divide both sides by negative 4. And I'm saying that p is negative 1/4. In other words, I'm moving to the left 1/4. So now imagine taking this point and subtracting 1/4 from the x value. Probably want to think of it in terms of a common denominator. That means it's negative 20/4 1. If you move 1 to the left, it would be negative 21/4, comma, 1. And that would be the focus. Notice the focus and the vertex are on the same horizontal line, so that y value shouldn't change. It just either moves right or left. And of course that would change if the graph or the parabola was opening up or down, then the x value wouldn't change. Alright, the directrix. Well, this number is still important. The focus is inside the parabola. The directrix, if you remember, is always outside. And if the focus is on the left, the directrix is on the right. Focus is up, directrix is down. Directrix should never touch the parabola, which means it has to be to the right of it this time. So again, from the vertex point, you're going to move to the right 1/4. In other words, you're going to add 1/4, which would give you negative 19/4. Now the difference is that the directrix is a line. It's a vertical line, so I'm going to say that the directrix is an equation. It's x is equal to negative 19/4. and there's my equation. Or of course, if the parabola is opening up, your directrix should be here, it would be a horizontal equation, so you'd say y is equal to whatever the case may be. But there's all the information you're looking for. The vertex, focus, directrix, there's the sketch of the graph. To get all that, all you need to do is make sure that you have it in standard form. Alright, so moving on to the second one. Asking us to do the same thing basically, so when I look at this equation, should be able to identify that it is a parabola. I've got one variable that's squared, the other one is not, so I know it's a parabola. And then I recognize very quickly that this is not in standard form. I don't see parentheses squared, and the question you should be asking yourself is, do I need to complete the square or not? And the answer is yes. And how do I know to do that? Whichever variable is squared, in this case it's y, that should be the only variable that you have of that. In other words, if I have y squared and that 4y is not there, then I don't have to complete the square. But if I have a y squared term and I have a singular y term, that means I do have to complete the square. So those two combined are telling me that, yep, I'm going to have to complete the square with those two. So what I'm going to do is I'm going to leave the variable on the left side that needs me to complete the square. Everything else will get moved to the right, which in this case is just the 4x. So I'll add 4x to the right side. And then what you're going to do is, if you have a number in front of the y squared term, you would want to factor that out. We don't in this case. So assuming that that step is done for us, I now take the b value, take half of it, and then square it. So I'm basically squaring -2, and I'm going to be adding 4 to both sides. Remember, we're trying to balance the equation. Whatever I do to one side, I have to do it to the other to keep it balanced. So if I add 4 to both sides, I really don't change that. And now the idea is, if I've done this step correctly, this should factor into a perfect square. And of course it does. It factors into y minus 2 and y minus 2. Kind of the rule of thumb is, or at least the rule that I kind of use is, whatever number that you squared in here, that's what's sitting in that parenthesis, or it's half of the b value, pay attention to the sign, is equal to, and I have this 4x plus 4. I'm going to factor out whatever that number is. I need, in the standard form, the x variable or y variable, if it had been y, I need that to have a 1 in front of it. So regardless of whether they have 4 in common or not, I need to factor it out. So it's 4, and then they happen to have it in common, so it's x plus 1. But even if they didn't, if this was a 5, I would say 4 and then x plus 5/4. Now I can rewrite this and say that it's y minus 2 quantity squared is equal to 4 times the quantity x plus 1, and now I have it in standard form. If you did factor, say, a 3 out, so there was a 3 in front, not in standard form because the square term should not have a number other than 1 in front of it, so you'd have to divide by 3, and then you'd just put the 3 there. Alright, now that I've got it in standard form, should be easy to find all my information. Going to start by finding the vertex point. Again, x is first, so it's -1, and then +2. There's the vertex point. It's y that's being squared, which again is, compared to last year, that's not normal, so it's opening to the right or to the left. This is a +4, so it's opening to the right. So my vertex point is -1, 2, and it's opening to the right, which means my focus is somewhere to the right of it. So if I look at my p value, it looks like p is equal to 1. So I'm going to be going 1 to the right, which means my focus, if I go 1 to the right, means I'm adding 1 to the x value. It's going to be 0, 2. And then the directrix, because it's an equation of a line, if I went to the right one to get the focus, go to the left one to get that x value, it's -1. Remember, it's a line, it's a vertical line, so its x is equal to -1. And so there are the 3 things that you're looking for again, and then there's your little rough sketch. Alright, so moving on to the third problem, we have find the standard form of a parabola with a directrix at x equals 3 and a vertex at 1, 2. So what I'm going to do is I'm just going to draw a quick sketch of this. You don't necessarily need to, but I like doing it. It gives you something to look at. It says that the vertex point is at 1, 2. So again, rough sketch. 1, 1, 2 is right there. The directrix is at x equals 3. If this was 1, 2, 3, excuse me. There's your directrix. And now I know the vertex point has to be somewhere in the middle of those two, and it has to open toward the, hold on a second. Sorry, this is the vertex. Okay, never mind. I know because this is the vertex, my parabola has to open away from the directrix, so it's opening that direction. So because I know it's opening to the right or left, this one is, I know that it should be y minus k quantity squared is equal to 4p times x minus h. It should be the y that's being squared. So I'm going to start by plugging in the vertex point since they gave it to me. There's the y value, so it's y minus 2 quantity squared is equal to 4p. I don't know that distance yet, or I kind of do, but I'm not going to deal with it just yet. It's x minus 1, my x value of the vertex. I've got everything I need except for 4p. Now I'm not going to solve for p, I'm going to solve for 4p, so I can think of 4p as a variable itself. The distance between my vertex and the directrix, if you look at these two, the distance is 2. So I know that p is either 2 or negative 2. Now you see that this is opening to the left, so p is actually negative 2. So if you plug negative 2 in there, you are going to end up with negative 8. So my final equation is going to be y minus 2 quantity squared minus 8 times x minus 1. And there's my parabola in standard form. Alright, and the last one, find the standard form of the equation of the parabola given by. So now they give you the parabola and they want you again to find the equation in standard form. I identify that it opens up right away, so I know the form of this parabola should look something like this. Up or down means that the x variable should be squared. They again gave me the vertex point, so I'm going to immediately start by plugging that in. That's usually what I want to find as fast as I can. So it's x minus the x value squared is equal to 4p times y minus the y value, which happens to be negative, so it's y plus 3. Now up here they gave me the directrix, or if they had given me the focus, I can quickly figure out the p value. They didn't give me the directrix or the focus here. So think about when you are given a point on a line. You typically have a random point on a line so that you can plug it back in to figure out the b value. Anytime you seem to have a random point on a graph, it's because you can plug that in for the x and y value, and then this is the only variable you'd be solving for. So that's why they give me the 0, 0. If I plug 0 in for x, whoops, plug 0 in for x, plug 0 in for y, you notice the only variable I have is p. Now remember, I don't really care what p is specifically. I'm considering this to be one number, like this 8. That negative 8 is representing both the 4 and the p. So I don't have to solve for p necessarily. So this is going to give me negative 3 squared, or 9, is equal to, I'm going to just put a box. That represents 4p for me. And it's going to be box times 3. If I'm solving for that box, divide both sides by 3, that box ends up being a 3. So my final answer is x minus 3 quantity squared is equal to 3 times the quantity y plus 3. Now if you do what I'm guessing a lot of you will end up doing, is you'll find out that that's 3, that's 4p, so you'll say 9 is equal to 12p, and then you'll divide both sides and get 3/4 is equal to p, and then you'll take the 3/4 and you'll multiply it by 4 and you eventually get 3 anyway. That's fine. You don't actually need to know what p is unless they ask you for the directrix or they ask you for the focus. Alright, those are the 4 problems to help you out with 10.2 day 1. If you have trouble, please let me know.